is very important, so I'll give a brief introduction about this. Then we all love C++, but we also know that C++ has a bad reputation for a lot of people because it's technical, it's difficult. And I will claim that C++ is not the problem. The problem comes from somewhere else. C++ just make it harder or more easy to fall into the traps. And I will claim that actually C++ can be the solution when it's well used. And that leads to my conclusion, which is that there's two levels of C++, the hard code one, and one for the people who are more developing features. And that will where we'll be discussing in the end. So before we start, there won't be a technical talk, like I'm not going to be showing some very hardcore C++. I wish I would. I would like to be showing something like compile time, regular expression, because that's nice. I've done some of this stuff. I can't show them because this is internal code. And anyway, that's not what I'm interested in right now. You will get some very technical and cool stuff for the two other speakers. Today, I want to talk about the low-level stuff, because the reality of my job at Google is I'm a plumber. I'm not an architect or a designer of nice things. I'm a plumber. I put things together. I do for loops, and if I push data through pipelines. And this is the reality of the job, and that changes the way you use the language. When I do C++ for my pet projects, I can be fancy. When I need to do something that works at scale, and I have 40,000 engineers working on it, I need to, work in a different way. And to give you a sense of the volume of things, those are my change stats at Google. So you can see that in 13 years, I moved about 9 million lines of C++ code. So either writing or deleting. You have to take that with a grain of salt, because you can see I moved 38 million lines of HTML and a lot of lines of Markdown. And the reason is because I was maintaining the backend for internal documentation. So I did a lot of refactoring, and I changed a lot of files that are the source of the content. But it shows you that what I do is I've seen a lot of code, ugly code, good code, robust code, fragile code. And that's what I want to distill today with you. So when I talk about the ecosystem, one of the things I realized is that I'm very lucky to get Google. I can write C++, I just fire my editor and it works, everything works. And I forgot, and this is the curse of knowledge, when you know something very well, everything fits in your head and you try to explain it and it makes sense to you and you forget to realize that for the other people, it's just very complicated. But recently, I tried to teach my nephew, or actually my wife's nephew, how to do C++. He's 17 years old, he's in Moldova, he's learning computer science, so he did Python, web, a bunch of things. And he wanted to learn C++, so I showed him. And because it's not just about programming, I wanted to show him the engineering aspect of it. So let's write a library, because you need to be modular. Let's compile it, because that's not so easy. That's the pipeline for releasing is important. And of course, test it, because I want you to learn the proper engineering practice. And I'm a big fan of TDD. So let's go. So open my terminal, fire something. I'm going to have a header file, a CC file, and that's it. And here's the code that we do. It's very easy. I assume you're all C++ experts, so it's going to look very simple. Bunch of boilerplates. Sorry, the declaration of my function. That's my header file. Then I go to my CC file, and same thing. A lot of boilerplate code. For the moment, I don't implement the function because I just want to have something compiling and a test. So I want to build. I'm lucky. I have been in my life an expert at Makefile when I was a researcher, and then in the industry at CMake for building. For the last 13 years, I've been using Blaze internally, which you might know externally as Bazel, and that has changed my life because it just works out of the box. So put this in a build file, and ta-da, it builds. Very happy. But when I look back at what I've done with him, the reality is I'm just writing the function, and that's what I want to say. That's just what I mean, right? And then I have to start with it. And here's the number of things I had to explain him. Preprocessor. Why do you have a preprocessor? Python, it doesn't have it. In other languages, you don't have it. Why do you have namespaces? Why do you need to put things into small boxes? Because if you work at the scale of Google, you can't have everybody calling class util. You need namespace. But then you have consequences. Things like argument-dependent lookup is very tricky. And as a consequence, we have very strict guidelines in Google. You can't have your own testing sub namespace because you have bad effects at a distance with the official testing namespace that we have internally. Then I have to explain about views, right? You have to be careful. Views are like pointers. You can have a dangling view on a string. And why do I pass my string by value? If it was a string, I would have a const reference, but it's actually faster to do it this way. And then I have to include something. Why the hell, for something as basic as a string in a list, which is available in any other languages, I have to include a header from a standard library? And this is include that system, which has brackets, right? But in the other file, I use local includes with double quotes. Why? Why do I have to know about this? And this is the definition of my function, and I have to learn the word definition, which is different from the declaration. I can have many declarations, but only one definition, and I have to be careful about the one definition rule. And the reason I need one definition is because there is a compiler that does compilation in it, and then a linker. This all those things that you have to learn. So the difficulty was not the language here, right? The difficulty was all those things around. Anything else you knew from doing Python and JavaScript before. But still, I managed to write some code to compile. And next was to test. So I'm a Google engineer. I'm going to use Google Test. Familiar with it? It's actually a good library. So that's it. Same thing. Standard stuff. Lots of boilerplate. What do we see here? Two more things. I have anonymous namespace because it's a good practice in your tests, so you don't, conflict with symbols that you might declare somewhere else. And then I have macros. Oh shit, I forgot that actually I have macros. It's so familiar for me to use this domain-specific language. So it's still a lot of stuff, but makes sense. It's okay. It's easy to compile. Same thing. Blaze give me CC test. That's good. I need to have an external dependency, but there's these amazing things. You have external packages in Starlark, so you just declare this archive, and that works. Nothing to do. It's just wonderful. Except that when you want to compile, out of the box, it doesn't work because Google Test is C++14, and the default installation for a bunch of things is actually not C++14. And this is where the fun starts. Like, if you want to configure your Starlark to build C++20, it's not easy. Like, you Google, lots of people trying to do that, and the official answer is this one, the configuration of tool chains. And this is a 3-day journey with a lot of documentation and things to read. So I went with a cheaty approach, like, you pass options on the command line, but it's not good engineering practice. Now, I can't put that into my Git repository and someone don't know, then just place build. I have to put instructions on how to build this stuff. Still, for the moment, it's okay. I can run my test. It doesn't pass. I'm happy. This is TDD. I can go to the implementation. Same thing. It's not tricky to implement. It's actually a fun interview question to start with. But here, I'm lucky. I work for Google. I know we have a bunch of libraries that have been open source in Absile for this kind of useful manipulation. So I use it. It's easy to write the function. Same thing, it's easy to depend on it. Once again, I reuse the same stuff I've done before. There's a bit of a trick because you need the skylib library. I don't know why, but that's it. And I have my test passing. So I'm happy, right? This was 3 weekends, 1 hour and a half per weekend of a GVC, working with him. And it was cool, I felt good. I could show him a full hermetic build. I had dependency management, and that package management is a huge area for C++. I could show him that we have testing support, decent libraries for a bunch of things that are not standard in the language. And more important to me, it was close to the middle. And it's a property I like of C++. I see everything that's happening. When I develop like personal web apps with Svelte and Node, I have all this magic happening. I don't know where things are happening. I put the log statements. I don't know where it appears. Here, I just have a terminal, a couple of files. I can touch everything with my hands. And also something that has changed compared to my early days in C++. I have actually now a read, edit programming loop where I can fire terminal, type a bit of C++, and immediately see the impacts. And this is very important because it was a huge argument for Python for a long time as a teacher that, hey, it's easy to try it. But now you can actually expand a bunch of C++ online with this. Now, what didn't work? The main thing is that it degrades very badly. And when I asked him to try to redo it by himself, he got blocked completely because it's easy to watch me do it. But then you do it and you make a small typo. So here's one example. Stay good. Can you spot what is the problem? Right? I'm not gonna, it's very small. I changed this. This is a lowercase c instead of an uppercase c. So now I've declared something, but I've defined something else. The linker fails. By the way, this is fascinating. The linker fails at execution time because that particular configuration of Bazel is using dynamic libraries. If I do the same code internally, it fails at compile time because we use static linking. All those things are tricky. There's no way for him from the error message to figure out what's happening unless you already have the expertise, right? So I choose also this example because I'll get back to linking later on the talks. Here's another example. Here, I removed the testing namespace before. And now I have an error that tells me, it's the wrong things. But because I'm in a macro, I have all this garbage around. And with some macros, this garbage is actually very, very big, especially if inside the call you have a template. Then, it's just Because, and this is very hard to debug when you have this, and it breaks your tool. If you're in VS Code, you have a lot of errors in your report and so on. The second big problem for me is that I'm actually missing most tooling. I wanted to show him how I work on my daily life, and I could not because most of the tools I'm lucky to have at Google are actually not available. And at Google, the tooling rocks. To be honest, that and the food is the main reason I'm staying. I have things like Clang format. My code is just entirely formatted correctly. I have Clang tidy running, discovering a bunch of problems on my code, things that just are easy to fix. Buell Cleaner is an amazing tool. I just put my include statement. I never have to care about my Buell files. It finds what is the library that provides these includes. Of course, I have auto-completion at scale, at the scale of millions of lines of code in our code base. I have full auto-completion working. And I have a ton of custom analyzer running on my code, finding, damning reference, all the stuff. And I try to get the same thing for the setup for him. Clang tidy, first thing you have to do to try it, you need to pass the include path. Oh, damn, I don't have access to this. This is just managed by the Buell system. And I'm happy to have Bazel because I don't have to care about the Buell system, but now I have to. I want to use Buell Cleaner. That's the official documentation. It's not supported for C++. It's supported for Go. And it will never be supported for C++. Because I happen to have the equivalent of this bug internally with a team discussing for 4 years why they won't do it, because it's utterly complicated and they don't have the resources. So I will never have this functionality. Then you have things like Edron project, where you can, it's going to automatically find how you build and start the LSP for you, the language of a protocol. But it's just like, once again, it's 1 week of setup. It's not out of the box. And it's not just because I work with VI and in the terminal. In VS Code, we have been unable to do it. We have a bunch of contradictory tutorial on YouTube, and we managed to just get the full installation of Visual Studio completely screwed up. So I don't have this tooling, but most of the things I miss is coming from this thing. So code search, I can talk about it because it's actually externally available. Code search and Kite is the way I can navigate my code. And it's very important because if you're familiar with the Flamingo book that Google published, writing code is one thing, but it's just a small activity. The main thing that I do as an engineer, as a plumber, is I maintain code. Code that has been written for 10 years or 20 years. And the challenge for me is to have something that evolves around time. And that is the light I'm going to use to explain you why I want to use C++ in a certain way, but not in the other way. And one of the things you learn in this book is that code needs to be navigated and read about 10 times more than written. And this is the challenge. So it's all about the tooling. So for that, this is our tool. So this is the external version of code search. I'm just going to open and show you the kind of things you have. So yes, you can navigate code, find your file. That's not what I care about. You have the classical stuff like the history of the changes on your file. This is the open source Kite project, which is the cross-referencing system. What I care about is that I can click on any symbol, like let's say the indexer reader interface, and I can find where it is used, where it is overridden, all the calls and all the stuff. And this is insanely good for managing your code base or for finding how things work. If I have a function I don't understand, I just look at a couple of usages, and from the usages, I can understand what this function is doing. So this kind of tooling is absolutely critical, and I need to have it to be able to work at Google. So that's a small introduction about the how you will use C++. It's not just about the language; it's how you're going to put it in practice. If I want to do a small parallel, it's easy to make a website that runs locally, and then you want to deploy it, and that's another story, right? So with that in mind, I found out after 13 years that C++ is not the reason why C++ has a bad reputation. So what is the problem? So the problem is that we're not programming, we're doing engineering, right? So my purpose is not to write code. My purpose is to launch a feature, to fix a user request, to speed up a system. And coding is just a mean to an end. And sadly, sometimes things are complicated, so I'm going to have to find shortcuts. And engineers, all of you, are very good at finding the loopholes. You can't do something, you'll find a way around it, right? And C++ gives you a lot of ways to do this. So the reason why we have problem with C++ is not C++ per se, it's because The way we use it for our jobs means that we have to hack around, and it's very tempting to hack around. And once you've done it, you don't have the time to clean it up because you need to move on the next feature. So I could be showing a lot of the classical things that you know about C++, but I choose two examples that come from my practice here, and that have been bugging me in the about 20 projects in which I work. The first one is error management. As you know, Google doesn't use C++ exception. Do you know what we use instead? The wonderful status OR. So it's a monad, the either monad in Haskell. And what it means is that when you have a function that returns a result, instead of throwing an exception in the function, which then would not necessarily appear in the signature, you return something that is either the object you want to return or an error, right? So far, so good. It works in a couple of languages. The problem is that when you start using it at scale, so you start having these kind of patterns. So you have to check if the result is good or not. And then, of course, if it's not good, you need to kind of report the error. Believe me, most of the time people do something like this. You just log the error and drop it on the floor. We have amazing tools for finding logs, so we're quite good with logs. That's how we make money. So this is what you start having everywhere. This is actually quite bad instead because it teaches people that you have to do local error management, where you all know from exceptions that what you care about is that the error should be caught at the top. This is the right place for dealing with errors most of the time. The problems start when you have this in function. The moment you have something calling a status OR, the function needs to propagate it back. So now I have contaminated because this thing here in the calculation returns a status OR. My function that is using it needs to return a status. And I need to propagate these things manually when normally the exception system would be doing it for me. So it's contaminating. So if someone makes a wrong interface where they return an error instead of finding a way to never have an error by contract, for example, now I'm contaminating my entire stack. Of course, this code is difficult. So what do? You use macros. You create your own language to make it more compact. But the moment you have macros, we have the problems I showed before. Your tooling is not working very well. And by the way, it's funny, if you want to have macros, even if it's from Absile, you want to have it by the Absile library, you need to get the protobuf library. Protobuf is another beast that could be a full talk, so I'm not going to go into this right now. Then the second thing that's happening, and that's causing a lot of problem in the code I have to maintain, by the way, one of my specialty at Google is I take system out of shape and I bring them in shape. So I remove codes, I realign the concepts, and I make things more efficient and leaner. So dependency injection, you have two aspects. One of them is the theory. You don't build the object yourself. What you need is passed to you at construction time. That's not what I'm going to discuss about here. What I'm going to discuss about is dependency injection framework. So things like Juice in Java or Dagger. There is none in C++, no official ones. There's a couple of attempts like Fruits. We have one internally. So what people do is that they invent their own. And there's a pattern that is used a lot, which is the C++ registry pattern, and it's bad. So let me show you why and the kind of engineering issues we have with it. So here's the problem. I want to have a function that I can load some contents from files. If it's just a local file, I can use the standard library for that. It works. But now I want to use this. I want to offer the same interface to all the Googlers, and I want to be able to read files from somewhere else, based on the prefix of the string. So here from a FTP server, in practice at Google, from a distributed storage file system that looks like a local file system called Colossus. So how do you do that? Well, you provide a file reader interface, and you let people implement it. So they will have some ways of getting the content. And then they do this. They have this magic macro that registers for a given prefix the class. This, under the hood, is very smart. Actually, people are very proud of writing this. You have a static object whose constructor is registering something into a global map that can be used by the function. You have mutex to be efficient, or a log-free map. This is smart, right? And then the way you use that, is in a build file. You just define your library, you link it, and for it to work, you need to put this magical always link. This tells the compiler to not strip and use symbols. And of course, you don't want to strip the static object because the static object, global, has a side effect, which is to register something in the map. The moment you do this, you're in a ton of problems. Why? You're not killing all the dead code from this library, and this is contaminating through all the things that are linking this. And you're defeating all the tooling. If I now go to my class and I click on the FTP file reader and I want to see where it's used, I don't get all the code where it's used. I just get the build rule. Now I have to find the build rule and all the things that depend on that build rule transitively. And now I have to find those of the rules who are binaries. I have to go to the source code and find where it's used. So I'm blind. And when I want to refactor, impossible. Also, all the tooling that is finding dead code, things that are no longer used, can't know. I have no idea whether I'm linking this and it is useful or not, because this binary is never reading from FTP. So I'm blind. And this matters because when you maintain a code base of our size, you need to be able to clean things automatically. So instead, what you would do normally, right? You would just have this in C++, use C++, right? Just at the beginning of your main file, register the thing you want, right? Now you have a header file, you just depend on it, no always link. And if I want to know where the FTP file reader class is used, I click on it in code search, and I get all the references, and I get directly to this binary, and I find it immediately, right? That just works. And even if I look at this, this actually still not good. Why would I have a global object, hidden as a static method? Because if it's global, I need to have some kind of mutex because I don't know where it's going to be used. I can just create my injector myself and pass it around, right? And the moment I do this, I can do some smart stuff. For example, here, I cannot dynamically check that not two things are registered on the same prefix. If I use a bit of smart templates, I can do this, and I can at compile time check that I'm not registering twice the same prefix. Hey, bonus! Now I'm detecting at compilation instead of runtime. One particular example of this very pattern is flags. So AppStyle as a library for flags, you can define something like this anywhere you want, and then you can access it anywhere you want. This is very cool for writing a command line tool. So in your main, that makes sense. It's also very cool for rarely used but very effective backdoors. So you have, let's say, your memory allocator has a parameter deep in the code. You can't inject this parameter through your entire stack. You never change it, except that one day you have an emergency in prod and you need to change the parameter. A flag is a very good backdoor. But this is too easy to use. So now people are abusing flags everywhere. Why? Because it's hard to inject something correctly in C++. So they have this thing available, so they're going to use it. And we're back to the initial problem, which is that people are finding ways around the difficulties. So the problem is not C++ per se, the problem is the lack of design, architectural, and engineering skills. So I'm not saying people are bad. I'm saying that these things are rarely taught. When I look, I was a teacher for a long time when I was in research. I'm now looking at people that are learning programming, like my nephew, but other people that I mentor. People learn programming, a bit of engineering, but they don't learn how to design a big system, And it's not like a small project, like designing something big and something that needs to be used by a lot of people all the time. And in your job, you rarely have the opportunity to learn this by doing the first version of your system, and then the second version of your system, and the third version of your system, because your management will not let you redo your system if it works, right? They will let you patch it. And in particular, there are a couple of properties that I've seen, lacking or not being, enough taught and enforced. It's everything about invariants. So can you define what are the invariants of your system? What is it that you compute? What do you want to have? And how do you enforce it through the particular language that you're using? How do you express the ownership and the concurrency model? If you do dependency injection, one thing that is very important is, do I pass you a row pointer because I keep owning it? Do I pass you a shared pointer because you share it with other people? Do I pass a unique pointer? Right? When I spawn multiple thread, at which moment do I join? Right? You have people inventing concurrency framework where you throw something out and you don't know when it's finished. And fundamentally behind is because not enough people, in my opinion, are leveraging the things that we've learned from functional programming, stateless function, algebraic types. So there's a lack of culture around this and the lack of opportunity to practice these things inside at your work. And finally, this aspect, a lot of people are looking at the programs and they forget about tooling. So when they have to choose between two options, they don't take into account the pros and cons of one solution when it comes to the tooling. Will I be able to detect where this thing is used so I can automatically clean it? And we'll see some example of this in C++. So here is a real life example. So I'm going to show you a dumb example. I trimmed down something, but it's a real example that happens. And it's very, very common. Someone designed a class, and this class is going to be stateful which means you have functions that you need to call in a certain order because it's going to store something in the object. And typically you have a command like this, it must be called exactly once, and you need to call prepare before. This works when it's used correctly. Then we have an outage because someone forget to call prepare when they use this library. So someone come with an action item that we need to protect, and you started seeing this code. So now I'm going to save a Boolean, and I'm going to fail, if you call a run without calling prepare. Sounds good, right? But the moment I do this, I introduce a status OR. And remember, this is contaminating. So now the entire call stack needs to manipulate with this. There's another subtle effect here when I do this, is I'm actually changing the contract. So here, when I choose internal error, I could choose failed precondition. What is the error message that I put here? It starts to become part of the interface of my class. So you could say, nah, I don't care about the error message because it's a failed precondition, you're out of the contract, I don't care what I'm returning. Except that if you work at Google, we have tooling computing the coverage. So if you submit the changes with this, the system will tell you, hey, your test is not exercising this line. So you're a diligent engineer, you want your thing to be green. So what do? You add a test that if you call a run without calling prepare, you have this particular error. Now this is capturing the test, it becomes part of your contract, and this is maintained forever. Of course, the moment you have this, people start thinking, hey, the reason I have prepare is because actually prepare is running on a different thread, and when it's ready, I'm going to call run. So let's be safe. Let me make that thread safe. So I'm going to put a mutex, for all those access, of course. And then, because I'm a good engineer, I'm going to put annotations around, so that the compiler and the tooling can find. So I believe I'm helping the tooling, but no, I'm not. I'm not fixing the problem. I'm just making it more complicated. And of course, the reason why I have this prepare and run thing is because prepare needs to be some very heavy setup. So let's say put a configuration. Imagine this is a very costly thing that is talking to the network. And I'm going to use it later. So because it's going to be initialized in this prepare function, not in the constructor, I have to use an optional as a member. And then when I'm going to use it, I dereference it. But now the tooling is telling me, hey, wait, you have an optional that you're not checking before dereferencing. So it's a potential problem. You have a client ID warning. So what do? I can make a check before, but I know it's never going to happen, right? I know conceptually it cannot happen. And also, I don't want to pay the cost of a check when I know it's not going to happen. Plus, which kind of error would I return? So, I ignore this. Instead, I put annulment, right? So I shut down the tooling. And this is how you have something that was bad in the beginning and that grows into something horrible. And then you jump into something and you imagine the amount of layers in the class, and you imagine why this is difficult. And then people show that to the manager and say, look, C++ is difficult. But this is not C++, right? And that makes me think about this joke, you might know. And I believe this is the reason why people don't like C++. Is because they look at bad C++ and they say this is the fault of C++. No, bad C++ is bad because it's bad C++, not because of C++ in the name. So I don't think C++ is the problem, and I actually think that C++ is the solution. So if you look at the example I showed before, you can do something like this, That's a proper use of C++. I'm not saying it's the smartest thing, right? But you can do this. If you're not allowed to call run before prepare, then you only have a method prepare on something, and it returns an object on which you will call run, right? So that's how you use it. And because you only want to call it once, you use R values. Now the compiler can figure out that you are calling it. It can be enforced at compile time. You shift left, which is very important. And you can even, of course, condense and do a lot of things. You have like a convenient syntax, and you have removed a bunch of the crap. And now if you want your config, that's easy. You just create a config in the constructor, no more optional, and that's it. Everything works. So if you leverage the power of C++, you can actually design something that has the property you want, that is simple to use, and where everything is checked by the compiler, and is actually even more efficient because you don't have mutex or checks or whatever. Yep, so far so good. So that's probably what you like here. Yeah, I'm smart with C++. I can do this very fancy stuff. I'm the hero. I'm doing this very complex template programming, whatever. But the reality is that C++ is actually very good for being in the mud, right? And as I said, I'm a plumber. That's what I do. So for the last moment in the talk, I want to show you some concrete low-level stuff where actually C++ has been very powerful for fixing, muddy problems. So here's the first example. There's a system where someone has this plugin class that you can override. And it has default implementation, we don't care. And the system is going to instantiate this plugin at the right place. Think, I'm dispatching some incoming requests on the server, and I want people to be able to implement their handlers. After some point, they discover that all the people who implement this method, they make a copy of data, they change something, they pass this copy to a downstream system. And this object is big, really big. So we realized, hey, we've learned our lessons. We're going to pass it by value and move it when we call the thing. And so people can do whatever they want with that data, much better. Now, the problem is, how do you migrate a code base of millions and millions of lines from one method to the other one, right? You can't make remember, Google is working at head. We don't have branch. So you need to fix everything into one go. This is not possible, right? So you need to have a way to be able to install the new mechanism and migrate things iteratively and then remove the old mechanism. Well, if you're a C++ expert, you can do very funny things with this. So first of all, if you have the two methods, you can have the old non-migrated plugin still working. It's still compiling. It has a default implementation for the method. You can write a new one. So you can tell every new user to write like this, or you can migrate things progressively like this. And then what do? You use traits. Traits is an amazing mechanism of C++ to extend things without modifying these things. So here I'm writing just like traits that are able to return, like to detect if I have one of the two other methods. And then I can write a function, a consequence function to test this property. And now this works as static asset. So my system, who is instantiating the plugin for the people, is able to decide, oh, this plugin is migrated. I'm going to call the move and pass them the data. This plugin is not migrated. I'm going to run the old code. And now I can run a 6-month process where I automatically send CL to people and I migrate my 3,000 users progressively, which I could not do. And this is a true story. So we did this. And we had a Java version of this, and the Java version, we could not do the equivalent, because at Java, you can't have signature overrides the same way that you have in C++. Here's another example, and the last one. We have this really big system, and there is an old method that we don't want people to call anymore. They should be calling the new method. But we have a few customers that we can't migrate. It's too costly, and they keep telling us, anyway, we're dead next year. We're going to delete the system, no needs for migration, and we keep doing this for many years. So how do you do for that? Remember, everything that's public is going to be used by someone, right? We have a single code base. So you can put something like this. This is really great. Absal deprecated. Now you can have tooling telling people, hey, you're using a deprecated function. If you go to code search, it's going to be shown strike through. So that's pretty cool. But still, people will use it. They will ignore the warning. So you can do this. You can say, hey, I'm going to make it private, and I'm only going to let my private users, my legacy users, use it. This doesn't work. Can you think of a reason why it doesn't work? So in that particular case, the legacy user is one of the register thing I showed you. It's just in a CC file in an anonymous namespace. You can't be friend to something in an anonymous namespace. It doesn't work. And anyway, if it works, when you do this, you suddenly give access to a bunch of other private methods, because you can't be friend, you're entirely friend or not friend at all. You can't be friend on just a few messages. And we don't have anything like package access, So how do you get out of this? Well, it turns out there's a very cool trick you can use. Just move the declaration of the definition of that function to another file, keep your old library, and make a new library with just the implementation. Contract the visibility with this, because you have the build space to control this kind of visibility. And now, if people try to use the old method, it will compile, it will fail at link time, which I said at Google is at link time that when you have a missing symbol, you fail. So I have been using the fact that you have declaration and definition, which I said earlier is a problem for beginners. It's actually a very powerful tool for engineering maintenance of a large code base, right? So that's exactly, you start to see where I'm going, is that in C++, everything that is dangerous for the regular users can actually be used for solving big problems. And so that's where I want to come. When I work in the game industry, the 3 years before Google, and they had this distinction between the game engine developer and the gameplay developer. And they're both programmers. There's no hierarchy. They're both good and smart. They're needed. You won't get the game without any of them. But they don't have the same mindset. The game engine developer, they're going to use C++, and they're going to use it at best to squeeze as many cycles they can from the CPU and display one more polygon than the competition. Also, they're going to design very smart API for allocating your memory, making sure that your network runs fast enough, that you have the right concurrency. For example, if you do sound, you need to make sure that your sound never lags, because it can make a twitch in the speaker, and it can make you deaf. The game developer, they have another job. They need to implement the gameplay that has been given to them. So they take something in plain English. When the boss comes next to me, it should start spawning goblins. And they translate that into code. So they do for if statements. But they don't want to allocate memory. They don't want to be managing threads. They don't want to do these things. So what you typically see is that a good game engine is leveraging the power of C++ to provide a constrained version of it that the people can use safely for the domain at hand. And so to loop back on my introduction, I only want to continue doing C++ at Google if I can work in that place where I'm using my expertise of C++ to constrain libraries or frameworks so that the people in a particular domain, not for everybody, in the particular domain I'm trying to fix, they can use my libraries in a very safe way, and they can focus on features, on what they need to do for their job, not on the intricacies of C++. And that's all I have to say.
So questions? First meetup, everyone is shy. I hope that by the next one we will have.
It's good I have a slide just after in case nobody has questions.
So I have a question: why you show, why you tell everyone that we write the bad code at Google?
Because that's the reality. I also write bad code. I look at some code I wrote even 3 years ago, and it's bad because it was good at that time, but I learned a bunch of things. And that's the important part of what I say. Sadly, I don't know, like for you, but sadly, as an engineer at Google, I don't always have the time to redo twice the same thing, right? A lot of my job is a one-time operation. You have a bug. It's not the same bug than before. I have friends, like when I work in computer graphics and in video game industry, if you're an animator, you have to do 20 poses for your character. You know exactly how many time you need for a pose. And if someone says, I need 40 poses and I need 5 characters, you can say, hey, that's going to be exactly that number of days. Me, I have a bug that comes, might be 10 minutes, might be 3 weeks of investigation. Something I deploy, 6 months of waiting to get the data, and maybe I understand what's happening. And I cannot predict, right? So I never have the opportunity to do twice the same thing, so I can learn from my mistake. In comparison, I own and moved in a lot of places, so I bought my kitchen 4 times. My 4th kitchen was really good, right? Because all the mistake I did in the first 3 ones, I solved them in the last one, and then I finally had a very, very good kitchen, and then I divorced. But other question?
Do you believe that the language standardization helps developers to write better code?
Yes, it helps because it standardizes some stuff. So, I thought C++ was dead a couple of years ago, and then C++ 11 came, and Lambda function changed a lot of stuff. Then auto came and changed a lot of stuff. I'm really hoping that the proposition that AppServer is doing about in and out parameters is going to come, because people are utterly confused by should I move, pass by value, by reference. But if we get this, that could be very good. So standardization and progress in the language is helping because it's removing, it gives the smart C++ developer the ability to make libraries that remove the burdens from the user, right? Still, the language is complex, but it does help.
So I have a bad news for you. C++ 11 came 12 years ago.
Yeah, I know.
Not a couple.
That goes fast.
So I have a good news for you and a bad news.
Yeah.
I still code in C, not C++, C and Erlang.
Ooh.
So, and I always said and I always had an argument with people that whatever C++ could do, I could do in C, in much efficiently. What do you think about it? I'm not against object-oriented, all these principles. So, I'm in favor of that.
So that's entirely right. And I can alone write HTML and CSS that is as nice as the complicated Angular application I have, and it's much faster and simpler. Nobody can maintain it. That's the problem. The key problem is that there's a huge difference between making your own library that you maintain and something that you need to leave to a bunch of people. Some of them are very good, some of them are just good, and problems will come. So this is for me the main reason, and this is why Go was developed. Go is not a nice language. Go was developed by Googlers because they knew, hey, if I want something that works at that scale with that number of people contributing to it, I need to get some engineering property, not some language property. Right?
Also, I want to contribute that actually costs of development on C is usually higher. You need more people.
So in the beginning, you mentioned Rust, but actually never came back to it. I'm interested in your view if Rust was able to learn from the C++ mistakes and whether that's going to be like the next generation C++ or they are going to exist in parallel.
Good question. So I'm not enough expert at Rust yet. As you know, it's been evaluated inside and they decided to go with Carbon because they think that some lessons were learned, but it's still too difficult. Like you can't put 40,000 engineers on Rust. You need something that is in between. The reason I want to go for Rust is I believe in web assembly very much. But I think that if you do that in C++, you might open security problems. So Rust seems to be a good way to be principled. So that's why I want to investigate it. But I don't have an educated opinion whether it is the right approach or not. I'm just very curious.
Do you think that old code is bad code? Like when C++ is always evolving, for you personally, when I learn new things about C++, I always feel that my old code that I wrote was like bad because there are now new ways to do it.
Yes, but so that's very interesting. So I'm going to do a small digression. We do design docs, we do postmortems, we do a bunch of things. And one thing very important I learned is you cannot criticize now the decisions that were made 5 years ago because there were good decisions at that time in the light of what you knew. What you can criticize is that knowing that you need to have a process as a company so that when you learn from a mistake, you can make sure you don't reapply it, and you have ways to fix backwards the thing that you have. Now, back to your code, it also depends which type of code you have. So recently I was reading something about the taxonomy of language or of software and products where they distinguish the E type and the S type. So I don't remember what was E, but S is shelf. So it's a library that you can do and you put on a shelf and you come back 3 years later, it still has value. So your sort algorithm still has value. It's a very small number of libraries that is like that. Most of what I do has a shelf life of a couple of years. In 1 year, it's been superseded by something, so I don't care. My job as an engineer is to take this huge system, which are mostly E-type, and try to find what I can take inside and that I can transform into an S-type that has a longer longevity because I can reuse it. And then either it's good enough, so I can take it as it is, that can be a library in C that I written and it's still valid, or I can revisit it later and say, oh, now that I have all those stuff, I can do this and that. But yes, when I look at my code from a couple of years ago, I'm like, oh shit, I could redo it like this now that I have this functionality.
Thank you.
Oh, long way to run.
Yeah, you need to ask a question.
Please ask in alphabetical order.
Yeah, sorry for the bad sorting. So somewhere in your presentation, you mentioned something. You pointed out that architecture, design principles, and things like that are not so taught or not so widely known. Maybe you could elaborate a little bit on that, or how resources where people could get started on that.
So I can elaborate. I can start from where we are. So I used to be in hiring committees, doing interviews as part of your job. Like 13 years ago, everybody would happily conduct interviews. We have a process. And I stopped doing this because the fact that people could write a red-black tree sorting or answer a puzzle game was absolutely not relevant when it comes to the qualities I need for the people I'm going to have in my team. I don't want someone that's writing very smart C++ that only them can understand. So when I look at what people are learning in school, at least from the samples I have around me, about 10 people, and when I read some of the news and some of the videos, people do a lot of programming. So they write small function, they do a small project for school, but they never do something like, hey, take this existing project that the school has been maintaining for 10 years, that was done by the previous student and the previous student, and fix it, right? Nobody does that. So nobody has the opportunity to take a complex stuff and to reflect about, oh shit, this is I don't know what we've learned from that, we could re-architecture. People do puzzles. They learn computer science, what is sorting, what is a red-black tree, the different properties, but they never do architecture design. And it's even worse than that. 10 years ago, if someone would send their resume to Google and it had something like software architect, it was kind of put on the side because it meant, oh, you're doing UML diagrams, right? But that's not that. That's not what I'm talking about. What I'm talking about is people that are able to conceptualize their stuff. And one of the big things I see is not technical depth, actually, it's conceptual depth. So you have a product, you start, you don't really know what you want to do, so you implement. And after a while, you understand the concept, right? So you say, oh, I have this and that. Those are the things that play a role in my system. Now you want your code to look like your concept. So your data class, no longer this vague data. You have the right name for it and the right API, but you can't change it. And this is where the tech debt is bad, is because you don't have tests, it's too slow to compile, you can't track the usage because, hey, you're not playing well with the tooling. So you are blocked to pay the conceptual debt because of the technical debt. But what matters is the conceptual debt. And this is what is not taught to people, in my opinion. Think in terms of concept, reevaluate your stuff, Is it necessary and sufficient? Do you have more if you add something? Do you lose something if you remove? All these kind of things. I don't see it taught and practiced by people. And we don't have the opportunity to do it at work. Never. This is my experience.
Do you think that C++ got better or worse in the last 10 years? Because the problem I have is that everybody agrees that 2011 was good, auto was good, and it got a bunch of features that it was long overdue. But now we have more and more stuff, and some of the things that come out, they just make understanding what the language does much more difficult, because even copy elision, it's great, but it changes the way you have to write code, and how you suggest to kind of keep up with it.
That's a tricky question. I'm afraid about this, and I'm not the only one. There's a bunch of people. We recently lost a very, very good long-timer of C++ at Google who left from the company. And knowing him personally, and I talk with him, it's being burned by the committee, by all the change of C++. So I don't really know. That's also why I'm diversifying my portfolio. Now, even if that happens, I can still have C++ with a couple of very good libraries, and that will still remain the same way. I will not use the new stuff, but the base will still be there. So I don't know how to edge my bets here. Yes, it might become very bad. But to answer your question about the last 10 years, it's much easier to build. Tooling like client format is a huge change, right? It's able to find your macros and to everything. So now we don't discuss formatting anymore. I can have LSC functions when I can rename a function or realign codes or find where something is accessing that via a pointer. I have all this information available. So it got better, in my opinion. Where it's gonna go, I'm not so sure. Now, one thing about this, the advantage of C++, and remember I said close to the metal, the problems are in your face. I've been using other stuff, JavaScript framework and Node. It's amazing. It works out of the box. And then it blows. And you have no fucking clue what's happening. This is all lit and there are layers of magic and it's very complicated. So you have a lot of stuff that looks like good, except that they're good in the beginning and they're not well after. The famous example at Google is YouTube. We bought YouTube. I was there. I started in YouTube. It was Python MySQL. It was burning money, literally. That's how I was running the computer. It took about 5 years to remove MySQL and to move to a better storage, Google size. And they are right now in the process of finishing moving from Python to C++ because Python is a nightmare. It's absolutely a nightmare at that scale. So yes, C++ is bad, but you know what you get.
But also, as you mentioned, you kind of have this separation, right, with C++. The people who supposed to write the libraries or the domain-specific languages, right? And so a lot of additions actually make the life of those people easier, right? Like the concept basically and the contracts, it's like. Well,
they change every few years. So before you used to pass basically constant reference every time when you pass heavy object. Now there are more choices. Are they better? They're quite often more efficient, but it's just more cognitive load on remembering all of those new features, and a lot of them are actually good.
For critical areas, it's good for us because they will need us. A couple of years ago, I had to optimize my code. Nowadays, I sometimes don't even use a hash map because, up to 200 elements, putting it in an array and running through the array is much faster than having the indirection of my hash map. So, they need to have the expertise to understand how it goes, how I can measure it, and which I should be using. There's a bunch of other language where, like we debug Java servers. It's ooming, it's going out of memory. Good luck.
Just add memory.
Yeah.
Do you have any strategy or experience that you can share about migrating to newer compiler versions, newer versions of the standard, like migrating to C++ 23? From my experience, it's meant to be easy because your old code should still compile with CPP 23, but in practice, especially large code bases and third-party libraries.
Yeah, I have the answer. I'm lucky. I work at Google. There's a dedicated team that does that via insane tooling. They're able to do a global build and running all the tests at scale over the night. I don't have to care. I have the up-to-date compiler, and everything works. That's why I make this first section, because it's easy to tell my friends, "Yeah, C++ is cool. Yeah, you do C++ at Google. You get all the comforts." It's like cooking is not hard. Every day they serve me dinner. So.
Thank you, Xavier. It's great talk. Thank you. We'll have the 10 minutes break. We'll have 10 minutes break. I think we'll open the door again, prepare the next speaker. And sorry, folks, a lot of stuff went not the right, like with the room you noticed, but also Danilo couldn't make it here. He lives in London and he has trouble with the Swiss visa. So Switzerland refused to, the time we live in, unfortunately. So sorry, he will join via video call. So we'll hear the talk. We'll have some discussions, but unfortunately, probably no offline discussions. Hopefully, we'll see him at some point when he will win the Swiss bureaucracy at some point. Yeah. So we'll meet again at 7:30. Thanks. Thank you. Welcome. It was great. Yeah. People, the event it's the first time, so a lot of people are new. There's no living community, so I hope the discussion. And I think someone, yeah. Oh, thank you. This one will be boring. No bullshit, but
what's up?
No, just.
I think the best introductions we ever made when we asked the candidate to add a new feature to the ID setup and thank you. I think the best exercises we can run is doing
you have to be accepted.
I'm humble because there's a department running hiring at scale. My previous thing